Okay, so if you pause and read this really quickly, we have a publisher's claim, 59% of readership owns a car, and a sample found that 55%. So the sample found a little bit lower than the claim, but we want to test how far away is this when we look at what we might expect normal random variation to be anyway. So if we go ahead and take a look at the formula sheet here, notice that we have uh, the formula for population proportion, and that would be our sample proportion minus population proportion over this. So let's set these formulas up real quick. Okay, so we'll get these two formulas. We need to solve for our standard error here first. So we have 58%, which I'm going to write as a decimal, very sloppily. Doing this with my finger tonight here, times 0.42, which would be 1 minus p, and that would all be over n here. And that would give us about, let's calculate that real quick. Just so you can see how I typed that into Google, I took the square root of the product of these. And if you want, just to be safe, you can put these in parentheses. And then you're going to divide by the sample size of 280. That'll still give you this value here. It said 4 decimal places. Let's go ahead and carry it 0.02950. 0.02950 there. And that would be right here, 0.02950. And then we'll just carry that up here. So we have our 0.55, which is what we got in our sample, minus 0.58. So we were a little below. We're going to go negative here. And then we're dividing that by our standard error. And I'm getting a z-value of negative 1.02. So if I'm going to draw a picture of this, I have a normal distribution here, mean. I'm sitting about negative 1.02. And to get the p-value, what we're looking for is all the values to the left of a z-score of negative 1.02. And let's go see if it's a one-tail or a two-tail test. That impacts if we're going to add anything over there also. So if we return to the question here, actually different from, so if it had said is less than the reported percentage, that would be a one-tail, and we would just look at the left tail. But it says is different from. Different from means it could be less than, or it could be greater than. It's a two-tailed test, which means, going back to our rather ugly picture here, also want this tail right here, and that incidentally is above the z of 1.0. So we want, in order to get our p-value, we need this portion over here and the portion to the right. Let's find what one of them is, and then we'll just double it. So we need to look up a z-value of negative 1.02 in our charts. So I'm going to go, I have a link here to all the tables in the frequently asked questions. And if we go to a z-value of negative 1.02, that puts us right here. That's 0.1539. 0.1539 would be the area in this left tail, but we need to, really missing my tablet pen right now. We really need to double that in order to get the p-value. The p-value tells us if the null hypothesis would be true, if it really is true that the portion of people having this car is 58%, what's the chance we would get a sample of only 55% in a sample of size 280? Well, there's a 15.39% chance we could get that 55% or lower. There's also another 15.39% that we could get probably 61% or higher, which would be the same distance away from that. And because it said different from, because the question itself said different from, we need to add both of those. So we're just going to multiply here this by 2, the 0.1539 should give us 0.3078. We'll go try that. 8, and that is incorrect. I knew this day would come. So rather than remaking this video, let me just show you what my mistake is. It says 59%, and you probably noticed this watching the video much before I did. I put 58%. Let's just correct it along the way. Maybe I'll do it in red here. So this should be 59, which means this is negative 0.04. Let me recalculate. That then gives me negative 1.36. So negative 1.36 is what I'm looking up on my tables. And 0.6 column here. Negative 1.36 is 0.0869. So that's the area in the left tail, and I need to double that. 0.0869. 869 times 2. And that'll give me 0.1738. And that is a much prettier shade of green. And just to clarify here, if I'm going to interpret what that p-value means, it means that if it truly is true that the publisher's report is correct and that 59% of their readers own that particular make of car, the chance that just by random luck alone, we would get a sample that's this large and that's 4 percentage points away from the reality in either direction, 4 percentage points or more away, would be 17%. We'd have a 17.38% chance of getting a sample percentage that far away from the true percentage.